Why do we need pointers? Well, I hope to talk about that in this video. The number one reason is because it allows us to create more efficient programs. And when I talk about efficiency, I'm talking about both time efficiency, so our programs could run faster, but also space efficiency. Pointers allows us to pass data to a function without having to make a whole copy of that data. And this is really important because sometimes our data is really, really large. And the time efficiency, I'm going to talk about an example in a minute to demonstrate that. But the other reason is because we can create variables and or arrays during runtime. So for example, let's say we have a program where we're asking the user the size of the array, basically. So if it's a program that has to do with students, we are asking the user how many students we're going to keep track of in the program. And based off of what the user enters, we would then create an array of that size. And we're creating it during runtime of the program. This is very powerful because it allows us to save this data in a different part of memory, which I'll be covering in this module. Okay, let's go back to the time efficiency problem. Here's an example. Let's say that we want to have students in the class sitting in stadium seating that has numbered chairs. And students are going to be in order by their first name alphabetically. And I have an array in my program that contains the first name of all the students in the order that they're going to be sitting. And so in this array, which I called student seats, you see that Ada is in seat 0, Alex in seat 1, and so forth. The array is 1,000 elements, assuming that we could have up to 1,000 students. And right now, this array, I want you to assume, is already filled up through 998. So technically, we can add one more student. Okay, so let's say we do want to add a student, and that student's name is Anna. So Anna, if we're going to put her in order, should really be between Alex and Ava. And so in order to insert a value in an array, especially at the beginning of the array, we're going to have to do a lot of operations to move the data out of the way, but still keep it in order. So we would have to move G to the element that has index 999, and then whatever the next one is over, and we're going to be moving all these array elements over one. So Dean will now be in seat 7, Cole in seat 6, Beth in seat 5, Ben in seat 4, Ava in seat 3, which will then clear up Ava, would no longer be here, and Anna could be here. So in a 1,000 element array, and we're inserting into the third element, that's going to be many, many operations. And just imagine if our array was even larger, like 10,000 or 100,000 elements. Many, many operations. There's another data structure. So an array is a data structure, but there's another data structure that could make this way more efficient. The data structure is called a linked list. And in a linked list, instead of elements, we have nodes. And each node is stored in a different place in memory, so not in consecutive places like an array. Also, each node is connected to each one with a pointer. And that is how you can get from one node to the next, is to follow the pointer to get to the next node. And so these nodes initially would be in order alphabetically, just like the array was. So I want to write Ada, Alex, and then we had Ava, and then Ben, Beth, Cole, and so forth. Okay, pretend that just keeps going on. And so now we want to insert a new student. We're going to use the same student, Anna. We create Anna in its own node, and then we create the connection from Anna to Ava, because Anna should become before Ava. And then we break the connection between Alex and Ava, and we make the connection from Alex to Anna. This was 3 operations. And no matter how many students are stored in this linked list, it's always just going to be 3 operations. So, and the only way you can do a linked list is with pointers. So this is just one example of how pointers can be beneficial in programs.